there, Mrs. Drossett here. So we are going to finish up the notes from this section, and what we're going to be doing today is we're going to be finding missing angles. So we've been working on finding the missing sides, now we're going to be finding the missing angles. So what we're going to be looking at is, if we're given the value, how can we find the angle? So if we're given the value for the sine ratio, how can I figure out what that angle is? Well, the way I do that is I need to do the inverse sine function. That's on your calculator. If you look right here, see how here's the sine button? There's the inverse sine button. So if you have a calculator like this, you can use it. If not, I'll show you how to do it on Desmos. So because the sine of 30 degrees, see, watch. First thing I'd have to do is check my mode, make sure that I'm in degrees, and I am. See how degrees is highlighted? So I can do the sine of 30 degrees. And look at the answer I get, 0.5. Now let's say that I'm given the 0.5 and I want to find the angle. Well, now I would have to push sine inverse sine right there. So I have to push second sine of 0.5, 0.5. And see how now it tells me what the angle is. So the angle of 30 gives me this ratio, or the value, if you want to call it a value. So if I know the value and I want to know the angle, I have to push second. All right, so let's do some problems here to practice. Okay, so looking here at this first problem, we're trying to find this missing angle right here. So if I'm going to use my calculator, I can look at my angle. This is my opposite, this is my adjacent. I have to know this SOHCAHTOA. There's the SOHCAHTOA. We have to know how to spell that correctly to be able to do it. So we've got O and A. O and A is what we have. We don't know the hypotenuse. We don't want to find the hypotenuse. So for O and A, we're going to be using tangent. So I set it up. Tangent theta equals opposite, which is 8, over adjacent, which is 5. So to figure out what that angle is, I have to do, if I have a calculator, I have to do, I'm looking for an angle. So I push second tan, which is right here, of 8 divided by 5. And then I push enter. And it tells me the angle is 57, and we'll go out 3 decimal places. So I'm going to say theta equals 57, and it's actually an approximation, so we use these little squiggles, 57.995 degrees. Okay, because we're going to round to 3 decimal places, 1, 2, 3. All right, so there's our answer for using a calculator. Let me show you how to do this on Desmos. So if I go to Desmos, let's push Desmos. Here we go. So I want to do second tangent. All right, that was my problem. Let me come back here for a minute. I need to do second tan of 8 divided by 5. So looking at Desmos then, I don't see anything for tangent or any of that. So I have to go here under this show keypad, and I don't see sine or cosine here, so I have to click on this functions, okay? And here it is, tan inverse. Now I'm going to show you that we're going to get the wrong answer, and then I'm going to explain why. So if I hit tan inverse of 8 and then use the divided by key, you can use divided by just on your keyboard. Right next to the shift is that little slash, that forward slash, and we get this answer. That answer is not right because that's the answer in what we call radians. You guys are going to have to come up here to this little wrench, go up to this wrench, and you have to make sure that you're using degrees. See how down here it says radians and radians is highlighted? We're not using radians, we're using degrees. And it's a shame because the default on this is radians, so every time you come in to use Desmos, you're going to have to switch it to degrees. And see how now it gives us the right answer, 57.995 degrees. And we get the same thing. All right, let's come here and do this next one. I'm trying to find this angle. This would be my adjacent. This would be my hypotenuse. So I look up here, adjacent and hypotenuse is cosine. So I say the cosine of my angle, theta, equals my adjacent, 7.3, over my hypotenuse, 8.1. I'm going to go back to Desmos, And I didn't exit out, and that's good because now I don't have to change that wrench thing again because I'm still in that degrees. So I have to go to functions. Okay, let's say we'd already closed this up, just show you how to get to it. Open that up, go to functions, and we're going to have to do, this time, inverse cosine, right here, cosine to the -1, and we do 7.3 divided by 8.1, and it gives us our answer. So theta is about equal to 25.679 degrees. Okay? Now, if we wanted to do the problem on the calculator, if you have one of these, you would push second cosine of 7.3 divided by 8.1, and it would give you that same answer, 25.679 degrees. Okay? All right, let's do another one here. So here's our angle, x this time. This is our opposite, and this is our hypotenuse. So we want to use the trig ratio that uses opposite and hypotenuse. And right here it is, opposite and hypotenuse is sine. So I do sine x equals opposite over hypotenuse. And I'm going to go to Desmos. I'm going to push enter on that one. I'm going to go to functions. I don't have to change it because it's already there. I'm going to do this sine to the -1. That's how I find an angle of 7, and then divided by is right next to that shift key, divided by 25. And we get the angle is going to be about 16.260 degrees. And that's going to be our answer there. So I just wrote it down, 16.260. I'll go ahead and do this one on the calculator just to show you. I would do second sine of 7 divided by 25, and I would get that same answer, 16.260. Okay? All right, this one is the same. So we're using that x, and we're going to want to decide which one we need to use, be thinking about it. Which one do we need to use? Here's our x. This would be opposite. This would be hypotenuse. What are we going to use? Look up here. We're going to use sine, right? So it's going to be sine of our angle x equals opposite, which is 8, over hypotenuse, which is 11. I'm just going to go to Desmos to do that. Right here, go to my functions, inverse sine of 8 divided by 11. And it gives me that angle. X is about 46.658 degrees. Okay? Pretty easy, right? On number 5, on this one, they're giving us all 3 sides. So you can pick anything to use. I can choose to use this and this, or this and this, or that and that, whatever I want to use. I'm going to choose to use, what haven't we used much? We haven't used tangent too much. Let's go ahead and use tangent. So I can do tangent of this angle. I'm going to call it x. It's actually alpha, but x is easier. So for tangent, I do opposite and adjacent. So I'd have to do 8 divided by 15. So I'm going to go back there to Desmos, push enter on this. I'm going to go to functions. I'm going to go to tan inverse of 8 divided by 15. And I get x is about 28.072 degrees. Now, you might be thinking, well, yeah, but what if I did it a different way? Well, let's say you decided to do opposite and hypotenuse, okay? Opposite and hypotenuse, that uses sine, okay? So I would set it up sine x equals opposite over hypotenuse. Now you wouldn't have to do it both of these ways. I just want to show you how we'll get the same answer. So if I come down here and I go to functions and I go to inverse sine and I do 8 divided by 17, see how I get exactly the same answer, 28.072? That's what makes trig so powerful, because we get the same answer no matter which one we use, no matter which trig function we use, as long as we're consistent. Okay? Why don't you try this last one on your own? Pause the video. See if you can do it on your own. Pause and then come back. All right, let's see. I'm going to use sine. I'm going to use a calculator too. You may have used Desmos, but I get 30.510 degrees. Okay, hopefully you got that. Maybe you chose to use tangent. If you used tangent, you would have done opposite over adjacent. You would have done this. You get that same answer. Okay? Pretty cool stuff, right? Okay, so make sure that you do the practice. Make sure you're keeping up with everything. If you need any help, just email me. We can set up a Zoom time, whatever you need. Okay? Hope you're doing well. Thanks for watching. Oops. Oh.